Carolyn. Thanks everyone for coming. Thanks for giving me the opportunity to speak. She summed up pretty much more what I'm talking about, so I'll get straight into it. A number of you may know that T has got a fairly strong soil science research team. Particularly recently they were involved in the National Soil Carbon Research Program. So that was Richard Doyle and Mark Sardi, Garth Coghlan and Bill Cochin, who's no longer with us, but he provided this graph, and this is kind of one of the major outcomes from that study. So essentially, if we start over on the far side, the amount of soil carbon that any soil can hold is mostly controlled by the type and the amount of clay inside it. The next major factor is rainfall and temperature, so weather, climate, and that tends to reduce how much carbon is available. So if it's dry and hot, then you tend to have less carbon. And then you have management factors, so what's the land use and how is it managed within that land use, and that gives you your actual soil carbon. A bit more specifically, as a general rule, you get a fairly substantial reduction in carbon when you go from pasture to a cropping situation. The variability is pretty high, but that just more shows the variability within the one soil type. If you do the fence comparison between pasture and cropping, you're pretty much guaranteed to see a drop. And the longer you crop an area for, then the lower the soil carbon is. So that's all well and good for cropping systems, but we're more interested in knowing what the situation is in a permanent pasture. So what opportunities are there to sequester carbon in a permanent pasture situation? So that's what our project's looking at, and we're funded by the federal government's Carbon Farming Futures Action on the Ground program. And our three main objectives are to build up some baseline data so that we can come back in the future and get a good feel for how things change. Work out what the comparative value of the various different strategies are in the real world on farm setting, and then extension working with the farmers and where the trials are, and the extension officers and researchers around the state to try to improve our knowledge. So the main things I'm going to talk about today are the field trials and our initial results, and a literature review that I've been working on. So this kind of encapsulates the strategies that we're looking at. It's a bit of a spread of, I've spread them out according to the sort of effect that they have on agricultural production. So some strategies reduce productivity and how much they cost to implement. So down here on the bottom left, we've got a great example of a north-facing slope. And so we've looked at a number of those. Then we've got native restoration, so biodiverse plantings, which are generally relatively expensive to put in, but you also get above ground carbon from those. We're looking at a number of Eric Hall's sown perennial pasture sites, where he's been looking at particular varieties of pasture to see how persistent they are. NRM South has got a number of holistic grazing trials, which is looking at how does high intensity rotational grazing, how well does that work for farmers, and so we're looking at soil carbon there. And then we're looking at a few organic amendments, so we've got compost treatment, a poppy waste treatment, and a compost tea amendment. So the design of the sort of overall project is that we've got 3 or more kind of replicates of each strategy. They're not exact replicas in the sense they're on different farms, they're in slightly different environmental conditions, but that should give us a bit of a feel for if there are any trends obvious. And we're doing cross-fence comparisons, and the reason we've done that is that soil carbon is notoriously difficult to measure precisely. And that's because there's a lot of variability both in space and in time. So by going with cross-fence comparisons, we can go to sites which have had a particular strategy operation for a number of years and look over the fence at a more normal, typical management scenario. And that should maximise our chances of seeing any difference. So this is just the method that we used at each site. It's a bit hard to see, but there are some little white poles which is marking where our samples come from. So we just take, essentially there's 4 samples on each for each treatment, and each of those samples consists of 3 cores that are combined. And then once we get the core, we're looking at the top 10 centimetres and the bottom 20 centimetres, so going down to 30 centimetres. And we're analysing that for total carbon, and we're using the now kind of standard, the accepted SCART methodology to do that. And we're also looking at the fractions, so the particulate and the humate fraction. And we're also sending some off to a commercial lab to look at active carbon, which is a different measure of labile carbon. So trying to get an idea of if a farmer wanted to get a feel for how his soil carbon is changing, then would these tests be, which of these tests would be affordable and effective and useful. The other things that we're looking at are looking at pasture composition, so trying to get a feel for how ground cover changes or the types of pasture change, and a subset of the sites we're going to put pasture cages in to look at pasture production. So some initial results. This is for the 9 sites that we've got data for so far. I've grouped them according to the kind of strategy, so we've got a bunch of grazing sites and a bunch of north-facing slope sites. In general, you can see that mostly there's not really much difference between the two, the control and the treatment at each site. Now, I should point out that we're not comparing the carbon between sites, we're just comparing within one site. That's what we're interested in. So just for the grazing sites, time-controlled grazing, you can see that here we've got quite a significant increase in carbon in the treatment, so that sounds all great. But then if you look at this site, there's actually a decrease. It's not statistically significant, but it's fairly substantial. And another site, we haven't had any change. And it turns out that actually it's probably something to do with the prior history, management history, that has caused this result. So that's one of the problems with cross-fence comparisons, that you can think that you've got a good site, but then once you actually delve into it and get it more detailed, it turns out maybe things weren't equal before the trial started. The other site that's got a significant difference is one of these north-facing slopes, and I'll give you a bit of detail into that one now. So this place, the landowners used to call it Ayers Rock, because it was basically mostly bare and really suffered from hardcore wind erosion. And then in the 80s they got some funding to fence it off, so they put this fence straight up the hill. So on the left-hand side, it hasn't had any stock in there for 25 years, and grass is kind of a metre high and dry and rank. And on the right-hand side, where there's still stock pressure, not a lot, but still does get grazed, there's virtually bare, at least it was in summer, or the start of summer. And if you look at the carbon, you've got 5% in the exclusion area and 4.3 in the non-excluded, in the normal area. And that's only a 16% change. So despite the fact that this has been locked up for 25 years and hasn't had any stock in it and has had a chance for all that erosion to recover, there hasn't been a huge change in carbon. And one of the reasons for that could be that literature generally shows that when you take livestock out of a grassland, you actually lose carbon because you are breaking the carbon cycle. So you end up with all this carbon standing up in the mass. It's not getting pushed into the ground and broken down and processed by the herbivores. The other interesting thing here is that the carbon stock, just at the top 10 centimetres, is essentially the same in both situations. And that's because the bulk density of the soil on the right is much higher because it's been compacted by the livestock. So that gives the appearance that it's got more carbon in the top 30 centimetres, even though it's got a lower percentage concentration. So that kind of illustrates some of the kind of methodological problems with measuring soil carbon. So just moving on to the literature review that I've been doing. There's fairly limited information looking at just pasture systems. A lot of the research has been into cropping systems. And when you look at it, there's not a whole lot of good reliable studies, but I went through and had a look at a whole bunch of different strategies and found what was there. And so I wasn't just looking at soil carbon, I was also trying to get a feel for what are the real and perceived costs and benefits to the farmer, so in terms of productivity or reduced erosion or various things. So I won't, I've got a few slides that look a bit like this, and there's a lot of information there, and I won't go into all. I'll just highlight a few interesting points. So with the time-controlled grazing, that was quite interesting because there's been a number of studies looking at how rotational grazing affects soil carbon, and it doesn't look like there's any clear story or any clear trend. But if you separate out the grazing trials where they've done really high intensity rotational grazing, otherwise known as time-controlled grazing, then you do see that there's an increase in carbon. I haven't put any numbers on what sort of increase because it really is variable depending on the soil type and your climate. And I've also got a list there for confidence. So generally, if there's low confidence, which is generally the case, there's maybe a handful of studies and maybe they need to be a bit longer. Perennial versus annual is an interesting question because often there's kind of this assumption that if you've got perennial grasses, you'll have higher soil carbon because you've got more roots and more root turnover. But from the studies that have been done, that doesn't seem to be true. What has been shown is that there are some key pasture species that do influence soil carbon, and that's particularly legumes and C4 grasses. The mechanisms are a bit unclear, but probably obviously with legumes, it's the nitrogen fixation. The C4 grasses is probably the efficient because they're quite efficient at using that nitrogen. In diverse pasture, so another way to accumulate carbon is to have high diversity pastures. So it's really interesting studies looking at increasing the diversity in number of species. So once you get basically having 2, 4, 8, 16, even 32 species, you get significantly more carbon by having those more species in there. And that's probably to do with sort of functional complementarity. So different sort of species fill certain niches and are able to increase production and increase just general microbial activity. Here in the phosphorus fertilizer has pretty good record of increasing carbon generally, and that's mostly due to increased productivity. But the problem there is that even though we've got some great, really 40-year studies, in one soil you might get no increase in carbon, and in another one you'll get a tonne per hectare per year. So even though on average you tend to get an increase, it really is very soil specific, and it's not clear what is driving that, what are the differences. And quickly, there are a few studies that, well, there's one study that's showing that dung beetles might have some potential, but again, we need a whole more research into that. So just a quick overview of what are the mechanisms that generally are acting in these different approaches to storing carbon. And often it's got to do with how much the productivity, how much biomass is being produced, but it's not always not that simple. It seems to have something to do, it can have more to do with the actual growth habit and the amount of standing biomass that is left in the paddock rather than how much is produced over a whole year. And another problem with this, with a lot of these studies is that, especially if you're applying fertilizer or irrigation, then you increase the fertility and the biomass production, but then you generally add more livestock, and so you increase the stocking rate. And those two processes tend to counterbalance each other. So even though you've increased total production and carbon inputs, you've actually the pressure of having the high livestock cancels that out, so you don't see any change. And another important factor in all this is how do the strategies influence microbial activity. So irrigation or liming tends to increase your soil microbial activity, sort of kind of primes it and gets it really going, but then that increases the oxidization of carbon, so you actually see a drop in carbon. So in terms of future research, we need some good long-term studies, which is probably, you can say that about nearly everything. Obviously, given the funding difficulties, it would be good to try and find good comparative over-the-fence studies like what we're doing, and then go back and revisit them in time as we're able to. We have to remember carbon's really hard and expensive to measure well. You can kind of do a bad job of it and get a number, then if you come back and get another number, it won't necessarily mean a whole lot, because it tends to be so much variability, and over time you can get a big change, and it's really unclear as to what's driving that change. So a couple of weeks ago we had a workshop which was basically inviting a lot of the researchers and extension officers to come together and discuss the state of soil carbon and farming in Tasmania. And so this is just a bit of a summary of some of those outcomes. It was really clear that there's no silver bullet, there's no magical thing that we can do that will increase soil carbon. But really, and different approaches work in different situations. They might work in one soil or one enterprise and not in another. There's a real need to mitigate against future losses. So with things like all the irrigation systems going in, such as in the Midlands, that's going to bring a lot of more cropping and more intensification to areas, which will likely result in lower carbon levels. So we need to focus on what can we do in those systems to try and avoid losing that carbon. In Tasmania, we've got a lot of farms that have got a very mixed enterprise, and whereas on the mainland, often they'll be more single enterprise focused, and so we really need a whole farm approach here, where perhaps farmers they might have a bit of land where they can put a revegetation plan in to offset maybe losses from a pivot that they put in. So there needs to be some methodologies that support that approach. Soil carbon measurement is hard and expensive to do, which really makes trying to account any carbon gains or losses really difficult and expensive, and probably prohibitive for a farmer who wants to make a small amount of money off carbon credits. So that's a big problem that needs to be solved. When you try to talk to farmers about why they want to take a strategy on, they're often asked, well, if I increase my soil carbon by 1%, how much is that going to increase my yield? And we don't actually have very good answers for that. It's not a clear link. Kind of makes sense from a soil health and sort of sustainability perspective, but we can't really put dollar values on the soil carbon itself. And there's long time frames involved, so not only does it take at least 10 years really to see any significant change in the soil carbon, but it's supposed to be locked up for 100 years. So most farmers aren't really interested in those sort of stringent requirements, and so obviously with the election that's just come, looks like we'll be moving from a carbon trading situation to a green army that's going to save us situation. So who knows what's going to happen with soil carbon or carbon in general over the next 5 years. So the final conclusion really was that we just need to continue to focus on soil health and good farm practice, and that will, if you do those things, then you're going to improve the soil carbon situation on your farm. And then once these other things maybe we bed down and get a bit more knowledge about them and a bit more certainty, then will be a good place to take advantage of it. So just finishing up, our project finishes mid-June next year. Got a bit of soil sampling to do over the next couple of months to finish up our sites, and we'll also be running a farm workshop and a couple of field days to try and get our learnings out there into the farming community. So we'd just like to say thank you to our project partners who are NRM North and South and Green Australia and Survey, and all the farmers who let us go and dig holes in their paddocks. Everyone in the project advisory committee has been really valuable in keeping us on track, and Mark and Suresh and a couple others who have done a lot of work in the field and lab. So, thank you very much.
Thank you very much, Garth. Any questions?
Did you consider fire at all?
No, but that's probably more of a problem in revegetation plots. But certainly, especially in the areas where you've got more grassland situation than a highly productive pasture situation, then yeah, grass fires would be a big concern. And that's one of the issues that really affects the whole carbon credit stuff, is that if you get a fire or a drought, then you lose a big portion of your carbon. I'm not sure how fire affects soil carbon. Certainly in peaty soils you lose a lot of it, but maybe you actually turn some of it into a more recalcitrant bird source. So yeah, I'm not sure exactly.
So, Garth, do you want to ask a question? Okay. It seems as if we're a long way away from being able to sort of account for carbon in the soil. And I thought Saro's technique was leading towards having something that consultants could use to advise about soil carbon content, etc.
Yeah, that's what they say. But
We can advise them, just may not mean
yeah, I suppose.
I wanted Garth's comments about that. I was trying to put it in a slightly different way.
There are definitely, I suppose I'm speaking from my experience of, we go in and we do a fairly homogeneous area, and we basically spend most of the day getting 24 cores out of the soil, and then we come up with, you saw the standard error bars on the graph, which they're just not, they're not that small, and you need to get a reasonably big change in carbon before you actually see it. So it seems hard to imagine that you could look at a whole paddock, let alone a whole farm, and affordably get that sort of information, unless you start making assumptions somewhere. Which, when if you've got lots of different soils in the property, like does happen in Tasmania and different enterprises, get pretty complicated.
I've got a very similar question actually. Just given how expensive and how difficult it is to calculate these kind of figures, can you see a day where carbon credits are a viable option? Local stuff?
They potentially could do something, but it would have to be on a less rigorous basis, probably. I mean, maybe there's potential in remote sensing. There's some developments there that could make that a lot easier. But yeah, you could come up with kind of some of the approaches that people talk about are coming up with what's a typical soil carbon for this sort of enterprise on this soil type in this area, and then from other monitoring that they've done, have an understanding, well, if you do this, then on average you're going to increase carbon by this much. So we'd be kind of happy to apply those kind of more general rules, heuristic kind of approach, maybe it could work. And maybe it will be more of a funding farmers to adopt good practice rather than being particular about actually measuring carbon. So they could say, okay, well, we're going to throw X million dollars at this, and they could have a statewide monitoring system that kind of over time would show that, well, you know, we've spent so much money and this is how our carbon's improved. So you can come up with a general approach.
Okay, let's thank Garth for his time.